Hi ladies and gentlemen, it's Mr. Green. This is another in my series of lessons on geometry. We are approaching the end of the semester, so these lessons are going to be getting shorter and shorter. We're trying to get everything taken care of. Do not forget, get your quiz corrections in. Make certain you don't have any zeros in the grade book, because we're going to make certain things are going to be going to zero real quickly, and that will be a really bad situation. We're looking at a special situation, a special geometric issue. Most of the geometry that we have covered in this semester so far has been flat. And that's the best way I can say it. It's just been flat. And you know what? Up until Columbus in 1492, that's the only type of geometry we ever had. It was called planar geometry, plane geometry, or Euclidean geometry. But after Columbus sailed the ocean blue and he came across the ocean, he kind of proved that the world wasn't flat. It was a sphere. And it changed everything. Why did it change everything? Because you could now go in a straight line and intersect yourself. And that changed the way that we looked at everything. And everyone was going, wait a second, we no longer have Euclidean geometry, we now have spherical geometry. Okay? So let's define a couple terms about spherical geometry. Spherical geometry says that if you're on the outside of a sphere, there is a circle that goes completely around the sphere back to where you are. That is called a great circle. Okay? Well, no, it's just called a circle. It's a circumnavigational circle. Okay? A great circle is one that passes through the diameter of the sphere. So if I'm looking at a diameter of the sphere going completely across the sphere and through the center, then this circle right here would be considered a great circle. I also want to point out this one here could be considered a great circle because the center of the sphere is right there, and this circle here going around it this direction would be considered a great circle. Great circle is one that goes around the sphere and intersects the diameter on either side. Remember, a diameter could be any line that passes through the center completely through. Okay? This circle would not be considered great spheres, but they are major circles that go around the sphere. Okay? Or some portion of the sphere. Cool? Cool. That's what a great circle is. Now, triangles in a circle. If I'm looking at a triangle, I could be looking at B, A, K. Okay? That could be a triangle. I could see that one, right? Well, how about the triangle B, A, M? Could that be a triangle? Why, yes, that could be a triangle. The problem with BAM is A is greater than 90 degrees, B is greater than 90 degrees, and it looks like M might be, a little close to 90 degrees there. We're talking about triangles that no longer add up to 180 degrees. We're talking about triangles that could have more than one angle at 90 degrees. Ooh, this is getting to be kind of funny. But as long as you're staying on the surface of the sphere, this is the way spherical triangles work. Okay? So, it can be tricky. Read the lesson very closely. Look at some of the problems very closely, because I think you will see you could actually get some objects that are very interesting. Remember, closest distance between any 2 points, between N and A, is a straight line. So I don't want to go through B, right? I want to go from N to A. It's still going to be an arc going around the outside of the circle, right? That's called navigation. It's going to help you when you get into the problems. Okay? I do appreciate you letting me know that you're in geometry. Make certain you come to tutoring if you have any questions. I'm trying to get everything wrapped up. Make certain you get it done before the end of the semester. I'll be talking to you next time.